Hello everyone, this is the first lesson recording for IM1, January 12, 2021. So this was just a quick brain teaser for you to get started with. All right, let's start with some announcements. You are going to have your first quiz for this semester. That's going to be next class. It's going to be on square root and cube root, and also deciding if the sequence is arithmetic or geometric, and finding common difference and common ratio. Okay, so you need to be very familiar with homework number 1 and homework number 2. What are we doing today? We are going to be talking about arithmetic sequence. Remember, that's the sequence where the pattern is or the rule is you're just adding certain number. It can be positive or negative number, but you are adding the same number. And for arithmetic sequence, we're going to look at multiple representation of it. And so you can represent sequences using graphs and using table and using and writing equations of arithmetic sequences. All right, so to begin with, you are going to be working on card number 1 to 4, where you're going to be reviewing arithmetic and geometric sequences and build tables from sequence list. So please pause the video and try that right now. Okay, so deciding whether a sequence is arithmetic, geometric, or neither. How do we figure it out? Well, you get a number from the sequence and subtract it from the previous, or I'm sorry, the next. So in this case, the next is 19. Take away the previous, which is 13, and that's positive 6. That means from 13 to 19, you added 6. Okay, is that the same for the next one? If I add 6 to 19, am I going to get 25? Yeah. And is that still the same? Yes. So since what you're doing, the pattern is adding 6 to each number, that this is arithmetic. What about this one? Okay, so to figure out if it's arithmetic, geometric, neither, let's see if it's arithmetic. So you get a number and the next. Okay, so I am going to go from the next, which is 6, and take away the previous, which is 3, and I get 3. So am I adding 3 to each number? No, it's not, because 3 plus 6 is not 12, and 3 plus 12 is not 24. In fact, first time it fails, I don't even have to go any further. So I know that it's not arithmetic. Then let's see if it is geometric. Okay, so how do I do this? I get the next number, so in this case 6, and then divide by the previous number. So it's going to be 6 divided by previous, which is 2. So that means I multiply by 2. Do I get the same num pattern if I keep doing that? If I multiply 6 by 2, do I get that? Yes. So therefore, this is geometric. So this is a geometric sequence. Okay, the third card. The below is the table representing an arithmetic sequence 13, 19, 25, and 31. Okay, when n is the term number, when n is 1, that means the term, we're talking about the first term, the value of the first term is 13. For the second term, when n is 2, the value of the second term is 19, and 25 and 31, and so on. Describe what do the values in each column represent. Where did the value 37 and 43 come from? Okay, so n represents the term number, and a of n is the value of the term, the nth term. Okay, so when n is 1, the value is 13. Or when n is 1, that means we're talking about the first term. The value of the first term is 13. When n is 2, we're talking about the second term. The value of the second term is 19, and so on. Where did 37 and 43 come from? Well, to go the common difference, what you're adding is 19 minus 13 is 6. So you're adding 6, and you're adding another 6 and adding another 6. If you keep going through that pattern, if I add 6 to 31, I get 37. If I add another 6 to 37, I am going to get 43. So that's how I got those numbers. So finally, I'm asked to create a table for the following sequence. Okay, so n is the term number. Okay, so we can say 1. We can write 1, 2, 3, 4, 5, 6. Okay, when n is 1, that means we're talking about the first term. What was the first term in the sequence? The first term was 77. What was the second term in the sequence? Was 68. Third term was 59. And then fourth term was 50. Okay? Now, do you see a pattern to that? What is the pattern? To figure out if this is arithmetic or geometric, you find a term and subtract the previous term. So it's going to be 68, take away the previous, which is 77, and that gives me negative 9. This tells me that going from the first term to second term, you added a negative 9, or you subtracted 9, or you added a negative 9. Same thing. You added a negative 9, you added a negative 9, or subtracted a 9. So you subtracted 9 or added a negative 9, same thing. So that means to figure out, and it matches 68 take away 9 is 59, and 59 take away 9 is 50. So to figure out the fifth term, I just take away another 9 from 50, so that gives me 41. And to get the sixth term, I take away another 9 from 41, and that gives me 32. And that's how you fill out the table. Okay, so let's summarize what we figured out. So if you have a sequence 77, 68, 59 to 50, then we can put the sequence, the first term, the value of the first term when n is equal to 1, or a of 1. In this case, a of 1. This case, a of 1. So n is 1, a of 1. So instead of a of n, now this is a of 1 is 77. In this case, n is 2, so a of 2 or a sub 2 is 68. A sub 3 is 59. A sub 4 is 50. A sub 1 refers to the first term in the sequence. A sub 2 refers to the second term in the sequence, and so on. Okay, so then this is how you figure it out. How do we figure out the rest? Well, we can figure out what happened. How did 77 become 68? I subtracted 9 from it. So I can say I subtracted 9 from it or added 9 from it. If I was to go from the list, I get the next number and subtract the previous number. So it's going to be 68 minus 77 is negative 9. And I get this number 59, take away its previous, that's 68. So 59 take away 68 is negative 9. And the last 50 take away its previous, which is 59, and that is also negative 9. Okay, so we can say that n refers to the position of the sequence, and a of n tells you the term value. So this is A of 1, A sub 1, A sub 2, A sub 3, A sub 4. And we figured this out because the common difference is negative 9. So common difference D is equal to negative 9. So we can figure out the rest, 41 and 32. And that's A sub 5 and A sub 6. So with that, I'm going to ask you to go on to card number 5 to 10. So please pause the video and work on those yourself. Okay, so this is card number 5. Here it says below is the graph representing the sequence 31, 33, 45, and 57. Describe how to graph the sequence. Start by explaining the following. For each point, what value should be used as the x-coordinate, what value should be used as the y-coordinate. Okay, so let's start by writing down what is the coordinate for this. So in this case, the coordinate x-coordinate is 1, the y-coordinate is 20. Okay, and in this case, x-coordinate is 2, and y-coordinate is somewhere between 30 and 40. I'm going to guess 33. Okay, and for this one, what is the x-coordinate? X is 3, and the y looks like halfway. So halfway between 40 and 50 is 45. Or maybe 46 was what this was. Actually, my error was the first one. It should be 1, 21. Okay, and then for the fourth one, it looks like about that is definitely 4 is my x-coordinate. Is 4 here, and the y-coordinate is a little over 55. I'm going to say 57. And this one, the x-coordinate is 5, and the y-coordinate is just under 70, so I'm going to put 69. And this one is x-coordinate is 6, and y-coordinate is 71, and so on. That's 7 and 73. Okay, so when you look at these coordinates, what do you notice? 1, 2, 3, 4, 5, 6, 7, and then the y value is increasing by 12, isn't it? Okay, so what do you think the x-coordinate is referring to? X-coordinate refers to the n value, isn't it? X is the n, which is the position or the term number. Okay, and the y coordinate represents the value of the sequence, value on the sequence, because 21 is referring to the first term, 33 is referring to the second term, the value of the second term, 45 is referring to the value of the third term, and so on. Okay, now for this card, you are asked to move the points to represent the arithmetic sequence with a of 1 or a sub 1 is equal to negative 4. What does a sub 1 mean? A sub 1 refers to the value of the first term. Value of the first term is negative 4. That means the coordinate for this will be the n value is 1. That's the 1 here. Okay? And the value is negative 4. So it's 1 comma negative 4. 1 comma negative 4 is right there. Okay, so I am going to bring that dot, whoops, to right here. And now for the second one, the common difference is 5. That means I am going to go up by 5. So when n is equal to 2, I want the value to be negative 4 plus 5 is going to be 1, and so on.